Let's finally take an example of customer segmentation, because clustering is very often used in marketing for identifying customer segments. Marketing analytics is, as a matter of fact, probably one of the most, if not the most, important fields in business analytics. That's why we decided to include a specific marketing analytics MOOC in this specialization as well. So let's take a relatively simple example of customer segmentation. In all the previous examples, we've mainly discussed how to identify different groups. We didn't really assess whether all those groups were really different. This is important because since we want to reduce the effort needed to act effectively, it may be that in some cases, some groups of observations, here some customers, even if slightly different, would actually be treated similarly. For instance, if you have two groups of customers that have different ages or slightly different product usages, but that are, at the end of the day, served in the same way, why should we consider them as different segments? Well, we shouldn't. Let's take a concrete example in the telecommunication sector. Let's say we have a customer base for which we have different information. For each customer, we know the average monthly national call time, the time spent in international calls, the number of text messages sent, the data used, and the age of the customer. We first need to normalize the variables again. They don't have the same units, so if we don't want to compare apples and pears, we'll apply the R-scale function again. Let's start to test what would be the result for 8 segments. We can then compute the average value for each of those variables per segment. This table reports the average values per segment provided by the hclust function for the case we selected. We see, for instance, that the first segment doesn't have a high level of usage, but is older than the other ones. Let's call this segment the silver. The second segment makes a lot of national and international calls, but fewer text messages. Let's call them the pro. We can then identify the segments young adults, 30-something, 40-something, teens, low usage, and expats. You can look at the exact data with the recital and the R code provided. But now, we notice that there are segments that, while statistically different, would actually be targeted by similar offers. For instance, the young adults and the teens clearly have similar usages, with fewer calls but a lot of text messages and data. Similarly, the 30-something and the 40-something are also very similar to each other. So let's apply Occam's razor and let's run the hierarchical clustering again, but with fewer segments. In practice, we could run several tests, but here we'll just focus on the case with 5 segments. We obtain another table. What do we see? We can distinguish 1, a heavy user segment, making a lot of calls, using a lot of data and text messages. 2, a young adult segment, using a lot of data and text but fewer calls. 3, a silver segment with a low usage overall, but more seasoned. 4, a pro segment with a lot of national and international calls and a lot of data. 5, finally, a light user segment. We created groups of similar customers to serve them efficiently. An efficient marketing strategy will define for each segment the bundle to offer at the right price, on the right place, with the right message. This message will be a function of what the customer needs, but also their social demographics. Here we only had 5 variables, but in practice we can take as many variables as long as the data is available and is relevant. We can also try to find a more visual representation than a table. You can use the many visualization libraries that are available in R, such as one providing a radar chart, for instance. A radar chart is a neat visual representation because it allows to compare multidimensional elements. each branch of the radar indicates the scaled value on each dimension of the segmentation. We can also do the same by exporting a table into Excel and creating the radar chart there. Actually, that's what I would do in practice, because I suppose you'll agree that R rarely produces pixel-perfect figures that can directly be showed to an external audience. At the end of the day, you want to make a presentation that is beautiful. It doesn't matter if it's done in R or in something else. Actually, nobody cares which tool you used. But if it's ugly, it won't give the impression to your audience that your work is of high quality. So when you report your results, for instance, as you will have to do with the last assignment of this MOOC, or the capstone project, pay a special attention to the presentation of your results and make sure the visuals are relevant, clear, and beautiful. We now can say that we've aimed at the best balance between cost and effectiveness. The cost to serve is as limited as possible because we reduce the number of segments ensuring economies of scale, and we implement specific actions for each segment having specific needs. That is, we ensure the effectiveness of our actions. The right balance between costs and effectiveness makes our actions efficient. We see that we use IT and statistics in conjunction with business acumen to converge to actionable and efficient conclusions and recommendations. For instance, to solve the question of how many segments should we have, we start from a reasonably large number of segments and we try to reduce it based on business common sense. How will it be implemented in practice, and how to achieve efficiency? We also pay a special attention to how those conclusions and recommendations are reported so that the resulting output is clear and obvious even for a non-technical audience. You will now have the opportunity to practice yourself thanks to the recital of the R script that will replicate the different examples we have discussed in this module.